Okay, well, we are officially a minute past the hour, so we will go ahead and get started. Hello, everyone. Welcome to the Decarbonizing Construction Innovations and Strategies in Reducing Embodied Carbon webinar hosted by Skanska. My name is Mark Chen, National Carbon Manager with Skanska. I sit here in our Seattle office, and I have the pleasure of being your moderator today. So a little bit about Skanska. We are a global construction and development firm. We guide clients and projects through sustainable initiatives as well as offer sustainability consulting services. We build in a wide array of sectors. So our goal today in hosting this webinar is to just share, so across all of the three panelists that we have today, experiences and best practices with decarbonization within embodied carbon, which we will get into here shortly. This is very important as far as our company's climate commitments. The panelists here also have, work for companies that have high sustainability aspirations. This topic of embodied carbon is becoming an ever important one with nearly 40% of carbon emissions globally coming from the built environment. Studies are showing that about 11% of that comes from the actual embodied carbon of manufacturing construction materials. So we hope you come away from this webinar inspired and with some tips and tricks to help you on your decarbonization journey. And so now I'd like to just introduce our panelists and speakers today. So there's myself. I just introduced myself as the moderator, but I'll hand it off to Katie.
Hi, everyone. My name is Katie Poss. I'm the Director of Global Policy and Procurement with Building Transparency. We are a nonprofit that is very focused on addressing embodied carbon and other environmental impacts in the built environment. We are the developers of the Tally Whole Building Lifecycle Assessment Tool and EC3, which I'll tell you more about a little bit later. My background, I worked with Turner Construction for about 5 years, spent some time with the National Ready Mix Concrete Association, and then joined Building Transparency in March of last year. So for the last 5 or so years of my career, I've been really hyper-focused on this issue of embodied carbon from the lens of the contractor, from the lens of the material supplier, and now from the tools and data perspective. But it's great to be here with you all.
Hi, everyone. My name is Jacob Denon. I'm a principal with CGF Architects out of our Portland office, and really glad to be here today. Worked with Tolga on the PDX project, doing a lot of LCA together, and then also have used a lot of Katie's projects. So I think this is a great panel to kind of really dive into this subject. And I think it's just sort of a really great time to be, interested and involved in sustainability as an architect, right? I mean, think about a decade ago, we were barely talking about embodied carbon, right? So to get a chance today to kind of talk to this group and this crowd, right, on like how do we actually do it moving forward, I think is a really exciting time. So super happy to be here.
Hi, everyone. I'm Tolga Tutar, a Senior Sustainability Director at Skanska. I also had the pleasure to work with Jake, Katie, and Mark in different projects. In my role, I oversee our sustainable construction practices and green building certifications, and I also lead some of our corporate sustainability commitments. As a company committed to carbon neutrality, I also support our carbon emissions tracking, reporting, and decarbonization efforts. And with a background in architectural engineering and sustainable construction management, I have been in the field for about 18 years. Thank you for joining us today.
All righty. Thank you, everyone. So before we kick it off, I did want to say that we received a really impressive number of advanced questions from some of our webinar attendees here today. We're going to do our best to answer some of those questions. We did receive many, so we likely won't get through all of them. Also, if you have any questions throughout this webinar, please feel free to drop it into the chat box here on Teams. And if we can't get to your question by the end of the allotted time, we will be sure to follow up with you directly. Last thing I wanted to bring up, please note that this webinar is recorded and we will be sure to send out the recording to all of the attendees here. So with that, Katie, let's start it off with you. So embodied carbon, let's just start with a baseline. We have a diverse group of attendees here on this webinar. So we wanted to start with the basics and then get into more of the technical details. So what is embodied carbon? How is it quantified? What are the tools that are available to our industry to address embodied carbon? And also, Skanska being a longtime partner with Building Transparency and co-developer of the EC3 tool, we also wanted to hear a little bit more about your work in supporting the ever-changing embodied carbon data ecosystem.
Yeah, great question to start off with, a big question. So I'm going to try to break it up into small chunks here. But just starting with the basics, when we use the term embodied carbon, we are talking about the emissions associated with materials throughout their life cycle. So through this process called LCA, or life cycle assessment, we are able to quantify the environmental impacts of manufacturing products, and we can even apply LCA at a whole project or whole building level. EPDs, or environmental product declarations, are public-facing summaries of the results of an LCA. And you might have heard them described as similar to nutrition labels for products. When it comes to tools, there are an ever-growing number of tools emerging on the market to support different needs and that serve different purposes. Specific to building transparency, we have Tally, which is a whole building lifecycle assessment tool and Revit plugin. There are other whole building LCA tools out there like One-Click LCA and Athena, but we also have EC3 underneath our umbrella. EC3 stands for Embodied Carbon and Construction Calculator. And it serves two primary purposes. One, it is an open access digitized database of just over 150,000 EPDs at this point, last time I checked. And it is also a calculator for building projects. I used to work in estimating when I was at Turner, and estimating embodied carbon is very similar to cost estimating. So with a bill of materials for your project and with EPD data, you can generate an embodied carbon estimate almost as easily as you can build a cost estimate. So again, there are a number of different tools out there on the market, and I encourage you to go, sign up for EC3 at buildingtransparency.org. I can drop a link in the chat. It is free, and if you ever would like a demo, I'd be happy to hop on a call with you and teach you how to use it. Beyond the tools that we provide, we are engaged in a number of different efforts to improve the overall data ecosystem. First, we are advocating for and working with program operators who are like the publishers of EPDs, and also working with the people who are generating EPDs to adopt a digital first publication. So historically, EPDs have been published as flat PDFs, which it makes it very hard for them to move from database to database or from tool to tool. So we're really trying to get more EPDs to be published digitally to support the interoperability of this data between tools and databases. I'm also very happy to announce that today, as of like 2 hours ago, we just published as part of the ECHO project, the V1.0 of the ECHO reporting schema. And this aims to provide a harmonized approach or structure for reporting project level LCA results. We see this as a first and important step towards enabling robust benchmarking efforts across the industry. The practice of conducting an LCA or estimating embodied carbon at a project level is becoming much more common. And we really need more publicly available data in a consistent format to better understand the true impacts of the buildings that we build and of infrastructure. I'll stop there. I think I could go on and on, but there are a lot of exciting things happening in this space, and it's really fantastic to see companies like Skanska and the AEC industry overall really stepping up to try to tackle this issue.
Yes, a whole another webinar could be dedicated to embodied carbon data. But thank you, Katie. So I think that really sets the stage well for the rest of our panelist questions. So I wanted to get into our next topic. So obviously, if this was all easy and if we all had it figured out, we wouldn't be here talking about this issue of addressing embodied carbon. So Jake, I want to start it with you, just from the perspective of a designer and an architect. What are some of the major challenges you've seen around addressing embodied carbon?
Sounds good. Yeah, if you could go to slide 17 of the deck, we can use that as a backdrop. I just want to say I could just listen to Katie talk about software development data probably this whole time, and that would be the best use of this hour. But yeah, let's see while you get that slide pulled up. There's a couple things I think that are worth talking about. Once we're sort of able to run analysis, right, we're getting more well versed in terms of just getting numbers out and starting to be able to quantify the impact of certain decisions. Now, I think with this level of analytics comes, certain responsibilities. So, slide 17, I think, is the next one. The first one would be about really just declaring our assumptions, right? This is true with any amount of kind of simulation or modeling, right? Garbage in, garbage out. We want to understand the assumptions, but it's especially critical for embodied carbon because we're just starting to wrestle with what these numbers mean. So this is an example of a slide I pulled from a different project that I showed before I showed the bar charts that we're looking at various strategies, because I mean, we need to kind of understand to know and to contextualize these numbers, a couple of basic things about just the scope of the analysis, right? What is the boundary, right? Are we talking about embodied versus operational? When you see a carbon savings number, right? I can't tell you how many times I see these two things conflated with each other or combined or separated, but not, clearly declared whether we're just talking about embodied carbon or we're talking about operational carbon. So like that's useful to mention. Also, if there's any type of wood that's involved, right, whether biogenic carbon is or isn't included is super critical, right? So, when you see a savings number, depending upon just that aspect, it's going to change, right? So this is an important thing to flag if we're showing any number that involves any substantial amount of wood, right? What is the LCA period can be useful, right? Especially as it relates to the boundary, which is that bottom series of circles, right? Like what are we including? There's like two different cradle to gate different boundaries, right? There's cradle to grave, but within that, like what actually is being included, it's useful to be able to declare that somewhere, right? When we're starting to see these numbers. Then also, what is the scope? So it's those boxes on the right. Are we just talking about structure above and below ground, right? Structure and enclosure is a really common scope because that's sort of what LEED requires, right? The ILFI is a little bit different. So, what exactly are we including in that is useful, especially because now we're starting to add more and more pieces of that scope over time, right? It's common now to see tiers numbers as part of a whole building LCA, right? Or even now HVAC numbers are just looking at sheet metal as one of the primary, impacts. So when we say whole building LCA, we have to contextualize that in terms of, well, what scope, systems, and assemblies are we talking about? Then at the very bottom of this graph is showing, the boundary, but also which software tool we're using, right? These software tools also vary quite a bit in terms of their data sources or even what numbers that you may get depending upon different boundaries. So it's always helpful to be able to say this was, done with Tally, or this was done with EC3 or Athena or one-click LCA, because that will contextualize those numbers even more. The last, challenge I want to mention is if we go to the previous slide, slide 16, this is a fun one too, and this is actually, I think, will ultimately be a strength. But who does the LCA modeling, right? We've been on projects where sometimes it's the architect, right? Sometimes there's a third-party sustainability consultant doing it. MEP engineers are now doing LCA, right? Or work with PAE. They're very well versed in LCA. Structural engineers, definitely part of their scope, and contractors. I mean, Tolga can run LCA and market as well too, right? So who actually does it? The answer is everyone. Right. And we've actually been in projects where we have a federated LCA model using EC3, where we each have our own separate scope that are all feeding into one larger model, sort of like a Revit project. So I think this has been a really great collaborative way to kind of work together and work on our different scopes in an online live modeling format that I think really allows us to dive into these questions. So that's sort of a challenge, but I think actually it's ultimately going to be a strength, especially with some of the tools that Building Transparency is working on. So yeah, it's an overview of some of the challenges that I think are facing us now as we move forward.
Yeah, plenty to unpack there. And Katie, from your perspective, speaking of things to unpack, also just from your perspective now that you've seen the GC side, the supplier side, and now the data manager software side, what are you seeing as some of the big hurdles?
Yeah, great question. I think I want to build off of what Jake just said, and it's great to see how ZGF is approaching this, and it really takes all stakeholders to be intentional about making it a collaborative effort. I think a big challenge sometimes is that oftentimes key stakeholders are working in silos, or there is a break in communication and collaboration between the owner down to the material supplier. And obviously there's a lot of people and things in between the owner down to the material supplier. And I think for embodied carbon reduction to be most successful, the owner, the design team, the contractors, the subcontractors, the material suppliers, especially for those key materials like concrete and steel and enclosure, some of those really impactful materials, they need to be talking to each other as early as possible. I understand that oftentimes due to contracting and procurement schedules, the GC or the subcontractors might not be on board until the design is fully baked and drawings are nearly complete. But to the extent that contractors and especially the subs and material suppliers who are experts in their materials, to the extent that they can have a seat at the table as early as possible to help identify reduction opportunities that are suitable for that specific project, the more successful reduction efforts will be.
And Tolga, from the perspective of a builder, I'm sure cost is always, I mean, for us, paramount. What's your take on some of the challenges you've seen?
Definitely, as a GC, he also encountered various challenges. Cost is an issue. There's cost premiums for certain products, but one of the biggest challenges is the perception of low carbon solutions as always having a significant cost premium. This perception is often misguided. While there can be significant cost premiums associated with newer products coming to the market due to their research and development costs or limited availability of those products in the market, many low carbon strategies can be cost neutral or even cost saving when evaluated with a life cycle cost approach in mind and early in the process with all key stakeholders. It's just important to note the feasibility of decarbonization strategies varies by project, but with proactive approach and considering all the factors, we can effectively integrate low carbon solutions without sacrificing affordability. But if embodied carbon reduction is an afterthought, then yes, there will be cost premiums for the projects. After the pandemic, supply chain disruptions and availability became another issue. We are facing this challenge for any kind of products, but especially for lower carbon products with limited availability. Those products might not be readily available in all regions, leading to difficulties in sourcing them or introducing uncertainty into construction schedules. And maybe another challenge, our projects obviously are subject to a complex web of regulations and building codes. These regulations can be fragmented or hindering sometimes the adoption of low carbon strategies and lacking sufficient guidance on reducing embodied carbon emissions. For example, codes often contain prescriptive requirements rather than performance-based criteria, sometimes limiting the use of low carbon strategies that don't conform to traditional specifications. And to accelerate decarbonization in construction industry and supply chain, I think developing more comprehensive and consistent building codes, regulation, and policies is essential.
Thanks, Tolga. And if I have my one soapbox moment to your earlier point, it's that, there are low carbon products on the market right now that have been used for years. We just didn't know necessarily they were low carbon because we didn't have tools like EC3 or EPDs to reference. So definitely driving that point home. When we say low carbon product, it's not this magical shelf of products that exist that live in a clandestine land. It's a lot of current and existing products that have been on the market for a long time. So we just talked through, the basics of embodied carbon, some of the challenges. Now we want to get to the fun stuff, which is the solutions and kind of the business case side. So, Tolga, I want to kick this one off with you. What are you seeing? What are some of the strategies, products, technologies, emerging technologies that you've seen or even implemented that can help address embodied carbon? Just for the folks here on the call, what can these attendees take back with them as far as solutions?
Sure. Very good question, and it can definitely be a semester-long class, but I will do my best. I think you mentioned that very well. Like when it comes to reducing embodied carbon in construction, it is important to understand there's no silver bullet. A comprehensive approach is necessary, evaluating and combining various strategies, product, and technologies. Maybe we can go over a couple of slides that I put together for today. There are definitely some overarching, like key embodied carbon reduction strategies that we can consider. First of all, really early engagement and coordination with key stakeholders are essential to identify and achieve low-cost, high-impact strategies for substantial embodied carbon reduction in project level. Early involvement of key stakeholders in the process allow them to provide very valuable feedback regarding procurement, cost, material carbon data, technical feasibility, and therefore identify more cost-effective and feasible opportunities to reduce embodied carbon emissions. And when, again, embodied carbon reduction is introduced to the process as an afterthought, teams typically lose many cost-effective and impactful opportunities in the process. From the technical standpoint, reusing buildings is really a very powerful solution. By repurposing existing buildings, structures, or components of buildings, we can significantly minimize the consumption of resources, reduce waste generation, reduce transportation and construction emissions, and prevent the demolition of buildings that often have very valuable materials. Building reuse almost always yields fewer environmental and carbon impacts than new construction when comparing buildings of similar size and functionality. Similarly, using salvage and recycled materials are very powerful strategies to reduce embodied carbon. By diverting materials from landfills and reusing them in new applications can significantly decrease the demand for virgin raw materials and eliminate the need for extraction, processing, and transportation, therefore reducing embodied carbon emissions. Maximizing material efficiency is key. Materials with the lowest carbon footprint are typically the ones that we don't need to use in the first place. With efficient design, planning, and resource optimization, we can reduce the quantity of materials that we need in construction. Moreover, limiting carbon-intensive materials is essential. As it has been underlined before, some of the materials like asphalt, concrete, and steel are typically very high embodied carbon products. So a thoughtful use is essential for these kind of products. Although these materials typically constitute a larger portion of buildings and structures' embodied carbon footprint, they also present actually a significant opportunity for impact. Even relatively small reductions in these material categories can have a substantial impact in project level. Therefore, it's really important for contractors and design team to work together to limit such materials and opt for lower carbon or even carbon sequestering alternatives. As Katie highlighted earlier, we have better transparency and easy access to embodied carbon data now. EPDs are great tools telling the life cycle impact story of a product. Project teams can choose like lower carbon alternatives based on EPDs and various freely available embodied carbon assessment tools such as EC3, Athena, EPIC, and more. And requiring EPDs and specifying low carbon products will help us ensure that necessary carbon disclosure is provided during the procurement process. Using bio-based products that sequester carbon can significantly impact the overall low carbon story of the project. While timber and mass timber might be the first options that come to our mind, considering other carbon negative choices like cork, bamboo, hemp-based or mycelium-based products will be other alternatives. But for bio-based products, it's important to understand and underline that selecting and procuring those products that are sustainably harvested is important to avoid negating their positive environmental benefits. Transportation of materials impact the overall embodied carbon footprint of project as well. During the construction phase, it's crucial to collaborate with our partners and carefully consider our transportation options. Avoiding air freight and using ocean freight, for example, for international source materials or choosing rail transport in lieu of trucking can make a significant impact in reducing transportation-related emissions. And similarly, we need to be mindful about our construction site carbon emissions to reduce reliance on fossil fuels. It's crucial at this stage to utilize like all electric or hybrid equipment as feasible, employing interim solutions like utilizing renewable diesel instead of regular diesel, or explore on-site or off-site renewable energy options for carbon-free energy generation. It's important to be mindful about construction site emissions in planning and design stages as well, because, for example, sites requiring soil stabilization or very deep foundations not only require more highly carbon intensive materials such as high strength concrete mixes or steel, but also they require heavy engineering equipment that relies on fossil fuels. So that's another example of an early engagement of key stakeholders. And lastly, minimizing waste is critical as well. As you can see, there's a correlation between number 4 and 10 in these strategies, but the emissions due to demolition and disposal of building materials is part of the embodied carbon story. And contractors and designers should prevent and minimize waste generation. Some of the strategies are like prefabrication and on-site waste separation using modular assemblies that are designed for deconstruction are some of the strategies that we can implement to reduce waste. And we have been evaluating these kind of strategies with our partners in many projects. Maybe we can go over a couple of the projects that we recently completed. If you go to the next slide, one of the projects that we recently completed in Portland, Oregon, is Shiloh Marcos Center for Design and Innovation. And this is a great example of adaptive reuse of a previously existing physical plant building in the university campus of University of Portland. And this physical plant building was transitioned into a new center to foster innovation and discovery at the university. And we were able to reuse the concrete foundation and retaining walls as well as structural and exterior wall elements that greatly reduced the embodied carbon footprint by about 42% in comparison to any construction option. And for the remaining materials, we were very mindful with our designer. All key materials have EPDs. We were able to do assessment with EC3 and TALI and identify like low carbon materials for concrete, steel, insulation, and other highly carbon intensive materials. And for the roof, a mass timber option was chosen, and we were mindful about our construction site emissions utilizing renewable diesel. So altogether, this was a great example of how comprehensive these strategies can be implemented. Another project is Canada Building. This project already has been one of the most sustainable building projects in the world, achieving several different credentials. But it's a great prime example of how reusing materials can significantly impact your embodied carbon budget. Our project team was able to utilize 12 different materials salvaged from demolition of different buildings or coming from different markets. For example, 2x4 and 2x6 lumber was salvaged from old movie studios and put together in the construction site as nail laminated mass timber panels used for the project. And the project is overall a net positive waste project, which means we actually generated very low amount of waste during the project. And thanks to the all salvage materials, we actually saved lots of materials that were destined to landfills. And this was also very cost effective for us because it happened during the COVID, and we were able to navigate around some supply chain issues with utilizing salvage materials. And maybe last project, this is also from Portland, Oregon. Sorry, I'm giving a credit to Portland, my home base, but this is a recent project that we are all excited about. I had the pleasure working with Jake on this project, and it's recently open to the public. It's a massive expansion project for the Portland International Airport. When it comes to decarbonization efforts, obviously large 9-acre mass timber roof comes to mind, but we were able to implement many circularity strategies like repurposing concourse connector, which was destined to be demolished. We were able to repurpose a large structure as bypasses for 5 years of construction, avoiding new materials, but also shortening the construction schedule and have positive impacts in the overall project budget. We were able to use also our own wood waste as salvage materials and new architectural wall panels, for example, which are all great examples how to reduce embodied carbon cost effectively. I can go on, but maybe I can share a couple of resources at the end, maybe in the next slides. We are really living in an exciting era. There are so many great resources, tools, documents coming from different companies and institutions. Oh, before that, maybe I can talk about low carbon solutions. Sorry, I forgot about that. We are implementing different low carbon concrete strategies in many projects. There are so many different ways to tackle low carbon concrete, but working with your local suppliers and understanding what is locally available is important. Also, looking for lower carbon alternatives to ordinary Portland cement, such as Portland limestone cement, can be impactful. Substituting cement with supplementary cementitious materials such as fly ash or steel slag, glass polyzone can be very impactful in reducing embodied carbon of concrete mixes. And right now at the industry, like we are seeing 25, 35, even 40% cement replacements with SCMs, but even going beyond that is possible. You're seeing a 70% glass pozzolan replacement that we piloted in one of our confidential projects in Seattle. We talk about performance versus prescriptive structural specifications. Working with your structural engineer and focusing on performance-based structural specs can unlock many opportunities. And evaluating different concrete mixes, admixtures for different users can also make a significant impact. And there are lots of promising carbon sequestration technologies and startups coming up to the market. It's important to pilot those products in your projects, giving them a chance to prove their concept. And also biochar, which has been used for centuries as a soil enhancement, will be a great solution as an admixture, as an additional component to use your concrete structures as a battery for carbon. And yeah, there's a lot to talk about. Again, there are lots of great resources out there. Some of my go-to resources that our sustainable team heavily contributed to in the recent couple of years are, we work with RMI, a leading nonprofit focusing on decarbonization, on 2 reports focusing on embedded carbon. These resources are all freely available. So if you search on Google, you can find a link very quickly. But first report focuses on actionable items on reducing embodied carbon, and second report focuses on low-cost, high-value opportunities. Also, building transparency, owners' carbon action network, embodied carbon action plan is a great framework to help owners how to start thinking about embodied carbon. Similarly, AIA and Carbon Leadership Forum published their embodied carbon toolkit for architects, a great guideline. And Associated General Contractors Decarb Playbook, which our team, actually Mark, heavily contributed to, is a great framework for contractors to think about decarbonization strategies. And if you'd like to get nerdy about what's the building reuse impact on embodied carbon, the Greenest Building Report by Preservation Green Lab is a great resource.
Thank you, Tolga. Lots of great content there. So there have been some hints and certain references to mass timber. So we wanted to talk a little bit about that as well, as far as solutions. Jake, where do you stand on mass timber as a climate solution? And maybe tell us a little bit about what you've been working on in the mass timber space.
Yeah, definitely. Full disclosure, I didn't choose this background, but this is a great background to talk to this point. If you could pull up slide 13, that would be great. And we're really going to talk about, strategy number 7 that Tolga mentioned, which is about choosing lower carbon sequestering materials, bio-based being one of those options. There's a lot of questions now around, mass timber as a climate solution. And we're going to talk about 3 ways that it makes this more true, right? Everything's a spectrum in this respect. The more criteria that we meet around what I'm going to talk about, the more and more we can be confident that we are doing right by the climate and having the impacts that we're hoping to have. So short answer is it can be, especially if we meet the following criteria, right? And so the way that we talk about this, at least internally, and the way that we message this to clients, right, is that there are 3 ways to win with mass timber as a climate solution. The first one is just the difference in manufacturing emissions between wood, structural components, even, glue laminated or engineered products, right, where we're actually introducing more intense manufacturing versus steel and concrete, counterparts, right? It's just fundamentally lower carbon intensities to, cut down a tree, mill it in a milling factory, and then turn that into a rectangular section versus even, using electric arc furnaces for steel and then concrete pouring processes as well, right? So that's sort of the first way to win, and that's the most, straightforward, tangible benefit. Number two is where it starts to get interesting because it brings up a bunch of different assumptions about biogenic carbon storage. So this would be the carbon emissions that are pulled out of the atmosphere by the tree during its growth stage, right? Trees sequester CO2, then that CO2 that's stored in the tree gets transferred into the built environment, right? And there's actually no benefit there. We're just transferring it from one place to another. However, if that forest regenerates, which is generally true in North America with most forest types, there's a lot of forest practice laws that require at least minimum regeneration, right? So we can generally count on that it regrows. And if we're good stewards of that carbon when it's in the built environment, i.e., we're putting it into long-lived, durable wood structural products that we know are going to be around for decades and decades, right? Versus single-use products or lower value products. Then what we've done is we've increased the amount of wood in the carbon pools of the built environment while the forest carbon pool regenerates on the landscape. There's potentially a net benefit depending upon our assumptions there, right? So the biogenic carbon storage is an additional way that we see a benefit, and that has a huge impact. That's usually what can flip it to have a negative carbon footprint or a positive carbon footprint, depending upon how you're looking at that. So it's a big deal. The third way would be climate smart forestry, right? So this is instead of the forest just growing back to the same amount of carbon they had before, what if we start incorporating practices that actually start to increase the amount of carbon stored on the landscape while it's producing wood products, right? That would be higher retention or longer rotations would be one of those, right? Growing bigger trees that put on more carbon over time than smaller trees at shorter rotations. All right, so if we go to the next slide, let's talk about that piece for a second, because when we talk about climate smart forestry, this is another one of those horizons, right, that we're getting smarter about in the way that we're starting to think about what this means from a design standpoint and a choice standpoint, right? But it's early days in that as well. So there's sort of 3 steps as we get to solidifying frameworks around that third way to win with mass timber, which is around what's happening in the forest, right? And we're sort of in step 1 right now, where we're trying to define the frameworks around what is climate smart forestry, regionally specific to different forest types, right? So in some cases, that's about putting more carbon on the landscape as you produce wood products. Or if we're talking about our kind of drier side forests in the inland Northwest or the east side of our region, the Pacific Northwest, it's more about carbon stabilization, right? It's actually reducing carbon stocks to make the trees in the forests and stands more resilient to climate change accelerated wildfire. Right, so we need these frameworks depending upon the region, like what's it mean for the Southeast or the Northeast or for Canada, right? That's step 1. And I would implore everyone to go to the Climate Smart Wood Group's website and read their definition of climate smart forestry, because it's really interesting. Step 2 is where we want to actually now start to connect that to procurement, right? We have mass timber buildings, they have supply chains. So can we ask the question of our mass timber buildings, what % of our wood is being sourced from climate smart forestry practices, right? We can get into transparent wood procurement. We can start to ask, our manufacturers and our mills where their wood's coming from and connect it back to those frameworks, whether that's the prescriptive practices that, could be in the guide from step 1, or starting to look at satellite data sets where we're looking at carbon stocks over time. So we can actually say we absolutely are sourcing from forests that are growing more wood over time as they produce wood products, right? I think that's the highest level goal that we want to do, is to support those forests that are actually increasing carbon over time versus decreasing it. And that gets us to step 3, right? And this is sort of out in the future, where now we actually want to tie to our net LCA, right? Somehow, whether it's a separate module or boundary or separate as an offset, but we want to be able to tie the forest carbon dynamics on the landscape to our buildings and the amount of net installed cubic volume of wood that are in our products, right? And there's different pilot approaches for this. EcoTrust has been really looking at that satellite data, understanding the carbon stocks over time, dividing that by the timber output based upon county level tax assessments, and then converting that embedded carbon benefit per round wood to the different products in terms of the recovery rates and actually getting to a way that you can connect it. And what we found is there's a high variation across the landscape in our region, right? So depending upon where you're sourcing from, it can really increase the amount of savings that you can claim for mass timber, or it can negate some of those. This variation is good and bad, right? The bad news is that there's high variation, so it makes it hard to calculate. But the good news is it matters, right? I mean, this can actually change our LCA data from like 2 to 7x, depending upon the studies that we're looking at, right? 7 times, right? The amount of carbon downstream manufacturing processes, the forest carbon can definitely outweigh that, right? So it's something that we need to, as architects, continue to advance forward and start to get smarter about the way we're dealing with forest practices and climate smart forestry applications. All right, and then actually, so what I'll leave you with too is sort of something that I heard from very first mass timber conference I went to, right, that talked about mass timber as a climate solution. And really, there's 2 ways we can mess it up. One is that we adopt it too fast without thoughtful consideration of the things happening on the slide, right, what's happening in the forest. The other way is that we don't adopt it fast enough, because we do know there are tangible benefits, right, to mass timber as a climate solution. So we need to proceed, faster, smarter, and more sustainably if we want to scale the solution to have an impact for climate change. All right, and that's mass timber in a nutshell.
Awesome. Thank you, Jake. And so mass timber, a carbon sequestering material, but one thing that maybe isn't talked about as much is that there are other carbon sequestering materials out there in the world other than wood and mass timber. And Katie, I know you've been doing a lot of research around those types of products, so I will give you the floor to talk about that.
Yeah, just quickly, I'm really compelled by this notion that we can store very large amounts of carbon in the built environment in various forms, but especially from this family of materials that is a huge, largely untapped resource. And these are like agricultural, rapidly renewable fibers and residues. Think things like industrial hemp, straw, bamboo, perennial grasses. We are seeing a lot of products emerge on the market that utilize these materials as feedstock. Hempwood Flooring, their facility is very close to my house here in Western Kentucky, just about 20 miles away. And they're working with local farmers to grow industrial hemp to use it to make their flooring product. And they also use a soy-based binder, which is low emitting, so it checks multiple boxes. Hemp wool bat insulation is being manufactured in Idaho. Structural straw insulated, which check the box of prefab and modular, which help with, safety and construction schedules on a job site, but also store a large amount of carbon. And I think a lot of people, when they hear about these materials, they probably think they're most suited to the backyard project or a single family residential project. And that's just not true. There are a lot of cases where these materials are being used and are viable on large commercial projects. I was just on a webinar yesterday that Building Green hosted, and we did a deep dive into bio-based materials. And Building Green just published a report. So if you're interested in learning more about the opportunities there, I'll drop that link in the chat and you can go check out the recording of that webinar. One more thing I wanted to address, which Tolga talked about earlier, which first of all, that top 10 ways to reduce embodied carbon slide was fantastic. I really liked that slide. You mentioned something about soil stabilization, and I wanted to provide an example from a project I was working on years ago. In the specs in the geotech report, it was a large data center project, so you can imagine the amount of earthwork that was required in soil stabilization. The geotech report allowed either cement or fly ash to be used as the soil stabilization. So we plugged into EC3 what the impact would be if we had used cement, and it was like 30% of the embodied carbon of the overall project, and just an easy switch to use fly ash. And have a significant impact on the embodied carbon overall. So I would encourage you, before procurement, before you sign contracts and like, wed yourselves to these materials, plug them into EC3 and just try to see where some of those hot spots are and see where you can have the biggest bang for your buck.
Awesome. Thank you, everyone. Very insightful. And I know we're running a little bit behind on time, so I did want to get to our last question and then get into the Q&A. So the last question is about market signals and demand in the industry. So Katie, just with your role at Building Transparency, what are you seeing specifically in the public sector, specifically in the US, but potentially also outside of the US when it comes to embodied carbon policy, either at the state, county, city, federal level, whatever it might be?
Yeah, so the embodied carbon policy space is rapidly evolving. There's a term you may have heard called buy clean. This is a procurement approach that incorporates typically GWP or embodied carbon thresholds on specific material categories. I believe Buy Clean California was the first Buy Clean bill passed in the US. Buy Clean Colorado just went into effect in January of this year, and Buy Clean, Buy Fair out of Washington State was just passed in the US this year. So there's a lot happening here in the US as exhibited by this map that Mark just pulled up. If you are interested in learning more about embodied carbon policy, the Carbon Leadership Forum maintains an excellent tools and resources on their website. They have the policy primer series and this interactive map where you can go and explore not just existing policies that have passed, but proposed policies and also policies outside of the US. Just to address one of the questions in the chat around, small businesses and the lack of EPD data from some small businesses. The reality is there is a cost to obtain EPDs, and there is time required and likely a learning curve from some of these manufacturers to figure out what data they need to collect and provide to get the EPDs. I think somebody mentioned in the chat earlier the exciting EPA grant announcement that came out this summer, around $160 million. That is going to nonprofits, directly to manufacturers, and to trade associations to help pay for EPDs. So this is especially for those smaller businesses who might not be able to afford them, or it might be a financial burden. They can go and work with a trade association or a nonprofit who received some of that grant funding and get some of that money to help them pay for the cost of EPDs, which is very exciting. And then outside of the US, I just saw this morning that in Ireland, state-funded projects can no longer use what they call SIM 1, which would be most closely related to what we call ordinary Portland cement or type 1-2 cement. This is essentially the cement that has the highest clinker content, which is the primary driver of embodied carbon in cement. So Ireland is like banning ordinary Portland cement from their public projects, state-funded projects. So we're seeing Buy Clean, we're seeing incentives, we're seeing policy take a lot of forms and shapes. I do want to acknowledge that for the Skanskas of the world and all of the other AEC firms that are building and working on projects globally, and you're seeing these policies pop up that might have slightly different approaches. And I can imagine how difficult it might be to keep up with the slightly different GWP limits or requirements of each policy. So I would just encourage you to get engaged, to utilize the interactive map here on CLF's website. Also, the California Air Resources Board is hosting a workshop tomorrow to collect feedback from the public on their embodied carbon policies. So I'll drop a couple of links in the chat, but just get engaged and try to keep up with the ever-changing policy landscape. There's a lot going on.
And Katie, you spoke a little bit about policy going on in the UK and the EU. And Tolga, I know you've been tracking some of the EU level legislation and requirements for public reporting.
Yeah, maybe quickly, one of the most important developments happening right now in the EU and the United States, more of an implementation of like significant carbon disclosure requirements for companies are coming to the market. The Corporate Sustainability Reporting Directive by EU mandates a comprehensive set of sustainable disclosures, including climate-related information for a wide range of companies. Also in the US, Securities Exchange Commission has proposed climate disclosure rules that will require public companies to disclose their greenhouse gas emissions, climate risks, and climate-related strategies. So these new disclosure requirements are part of a global trend towards greater transparency and accountability in climate related reporting and impacting the project requirements for new development projects for our private sector clients. We are observing more stringent requirements around embodied carbon, especially most of our high-tech clients that are public have commitments to carbon neutrality, and therefore we are seeing more stringent requirements around embodied carbon for high-tech campuses or data center projects and more.
Awesome. Yes, lots of in all of these different buckets and spheres of embodied carbon, so much to keep up on, especially on the public policy side. So that was everything for our preset panelist questions. We did want to get into Q&A, and I see there have been many questions from the audience, which is great. And I'm trying to keep up with all of the questions and the responses in the chat box. I did notice one that I wanted to bring up with you, Katie, and that was one about the concerns of using different tools to complete LCAs. So like we talked about, there's EC3, there's in this question, there's a reference to one-click, there's Tally, the Athena estimator. It's almost overwhelming when you sort of look at all the different LCA tools out there. So Katie, where do you stand on the use of all these different sources of data?
Yeah, it's a great question. I remember when I first got into this space, I was attending a CLF webinar and I asked the presenters, if I put the exact same building project, the same bill of materials into 3 different tools, Tally, OneClick, and Athena, will I get the same result? And the answer was no. So digging into that deeper, the reason is that there are different background data sets in each of these tools. You know, EC3 primarily uses product-specific and industry-wide EPD data. You can select the actual product EPD if you know the product you're using. Whole building LCA tools are commonly used earlier in design where you might not know the exact material that's going to be used, but you know that it's going to be a mass timber or a concrete frame, and you can model the materials and the quantities without knowing the actual product. So I say all that to say that comparing results between tools is not an apples to apples comparison. We do have a link between Tally into EC3 where you can export results from Tally into EC3, and essentially the designer could hand it off to the contractor where the contractor would true up the model with as-built quantities and as procured EPDs. But I would just use caution when you're analyzing results from different tools, and just understand that there are different background data sets, generic data sets like Gabby and Eco and Vent. Then there's industry-wide EPD data. Then there's product-specific EPD data. Use caution, and if you're interested in diving deeper into this, I'd be happy to talk offline, but not apples to apples across tools.
Absolutely. And again, the ever-growing and changing data ecosystem. So man, there's so many great questions that are in the chat and also that we received before the webinar, and I'm trying to identify maybe the best 1 or 2 here with the remaining time we have. But maybe let's talk about concrete, because we just got a chat question about using fly ash in lieu of ordinary Portland cement. And of course, concrete's always such a hot topic in the embodied carbon world. So I guess starting with the chat question, Katie, you mentioned the example of using fly ash in lieu of ordinary Portland cement for earthwork stabilization, and I see you're also responding here. So I guess why haven't we switched over to other cementitious products other than ordinary Portland cement? Like, what are some of the limitations?
Yeah, it really depends. And I'm not a geotech civil engineer, but it really depends on your location and the soil conditions of where you're building. But for your specific project, work with your geotechnical engineer and your civil engineer. Ask them what is suitable and what your options are. Typically, the geotechnical report will tell you. In this particular case, cement, limestone, and fly ash were all allowed based on the soil conditions in that area. But yeah, it really comes down to more broadly project-specific solutions that might not be a one-size-fits-all solution for all markets and all projects.
And I will add on there too, where does fly ash come from? It's a byproduct of coal-generated power. And so as we transition away from coal power, we're seeing the fly ash supply starting to take a hit, which, it's funny because it's a positive step in the right direction overall, but it does affect some of that supply chain availability for us on the concrete side. Which goes into maybe our last question that we have some time for. And everyone's always asking this, how do we as an industry balance, optimizing and reducing embodied carbon with all the other things that go into a construction project? So mainly budget, but also supply chain availability, performance, warranty, the myriad of things we need to consider for our projects. And Tolga, maybe we'll start it with you.
Sure. Again, like early engagement of key stakeholders, bringing everyone to the table and looking for like high impact areas is key. It's hard to win all different aspects of sustainability, but focusing on, I guess, 80-20 rule, where we can make the biggest impact with most feasible and low cost solutions will be a great start, and try to stretch from there. Definitely cost is a barrier. We are working for profit companies, and our clients have certain budgets, so we have to be mindful about that. But there are many sustainable options that where you can have a low carbon and sustainable products and materials incorporated into your project cost effectively. So that's important. And also to keep in mind, like companies like us, for example, have been around for a century, and we would like to be here for another century. And this is the only way. Like lower carbon is not a gimmicky add-on item. This is the only way moving forward. Climate action is urgently needed, and as an industry, we have to transition to that. And if more and more projects start incorporating like embodied carbon reduction strategies, this will be a new normal moving forward. To give you an example, LEDs was a like new technology 15 years ago. I remember LED fixtures costing like 3 digits when I first started my career. They are dirt cheap right now. Like it's no brainer, and it will be the same thing for many low carbon, low embodied carbon solutions in the very near future as we implement them moving forward.
Jake, with 2 minutes left, anything you want to add there?
Yeah, I think what's really interesting about doing this kind of analysis is that we can now start to look at different financial criteria for making decisions, right? There's the hotspot analysis, or like finding what's like having the big impact. As we start to push down further, carbon frontiers and really drive the embodied carbon of our projects, and we have to do everything, right? And what this allows us to do is to look at the cost of carbon per any decision, right, from an embodied carbon standpoint. And some of our clients use that as an investment making mechanism, right? It's like we'll do any sustainability strategy that has a cost per ton of like under $100 per ton, right? And that would be, even if they're small, right, it gives us a way to kind of make a valuation of those different decisions that could add up over time. So we want to understand the kind of cost efficiency of doing those types of optimizations and the absolute amount of carbon, right, that can be saved based upon the hotspot analysis. So that's one way that we've been starting to try to prioritize or do the analysis that starts to get carbon now in there with all of the other considerations we have to do.
Awesome. And with that, with a minute left, I think we will end the webinar here. Like I said, a recording will go out of this session just so everyone can refer back to it. And we will also try to get responses to you all for questions that we weren't able to address in the hour provided. But thank you so much again. We appreciate everyone tuning in, and thank you to our panelists for their insights, and hope to see you on the next one.
Thank you.
Yeah, thanks so much, Mark, for
Thank you.
facilitating.
Thanks, everyone.